Let's look at section 10.5 where we'll explore some word problems. In example 1, the height of a triangle is 5 centimeters less than its base. The area is 18 square centimeters. Find the base and the height of the triangle. For most word problems, it's a good idea to draw a picture of what's going on. So we have a triangle, and in this triangle we have a base and we have a height. Recall the formula for the area of a triangle. The area of a triangle is equal to 1/2 base times height. So this is a formula that you should memorize. The area of a triangle, again, is 1/2 base times the height. Then I list what we know. So we are looking for A, B, and H here. We want to know what we know and what we don't know. So what's the area? The area is given as 18 square centimeters. So we could write down 18 for the area. The height is 5 centimeters less than its base. The height is not 5, it's 5 centimeters less than its base. So for the height, I'm going to write the base minus 5. We don't know what the base is, so we'll leave that as an unknown, but we know the height is whatever the base is minus 5. So that's going to help us quite a bit. We can substitute into the equation now. The area is 18. That's equal to 1/2. The base is unknown, so we'll leave it as B. But this H right here, we could replace that with the height, which is B minus 5, or the base minus 5 centimeters. So we'll substitute that into there. Now I don't like that 1/2 in front of my fraction, so I could get rid of it. How do you get rid of that 1/2? I can multiply both sides by 2. So that's what I'm going to do here. We're going to multiply both sides by 2 just to get rid of those fractions. So this gives me 2 times 18 is equal to 2 times 1/2 b times the quantity b minus 5. What happens to the left side? That's 2 times 18, which is 36. And that's equal to, you can see right here, the 2 and the 2 reduces, leaving me with just b times b minus 5. This is good. We don't have any fractions now, and so we can distribute the b. Let's distribute the b. This gives us 36 equals b squared minus 5b. Now this looks like a quadratic. We have power of 2, so we want to set that in standard form. So we'll start by subtracting 36 to both sides. We'll subtract 36 to both sides. And that means our equation is now equal to 0. So we have 0 equals b squared minus 5b minus 36. Now hopefully this thing could factor. Let's attempt to factor. We have a negative 36 on top and negative 5 on the bottom. What two numbers multiplies to get 36 or negative 36 but add up to get a negative 5? So that's a positive 4 and a negative 9. So this factors as b plus 4 times the quantity b minus 9. If I set each of these factors equal to 0 to solve for b, I get the following. B plus 4 equals 0, which implies b equals negative 4, or b equals positive 9. Now one of these doesn't make sense, and that's the base being equal to negative 4 centimeters. That does not make sense. You can't have a negative distance. So the correct answer is b equals 9, and it's centimeters. So the base is 9 centimeters. But we're not done yet. We still have to solve for the height. To solve for the height, we need to go back and look at this equation here. We know b minus 5 is the height, but I know the base is 9 centimeters. So we can just substitute the 9 into this equation. So we have h equals 9 minus 5. So the height is going to give us 4 centimeters. So that's it. The height is 4 centimeters and the base is 9 centimeters. To check my work, I could substitute 4 for the height and 9 centimeters for the base and multiply by 1/2. So let's do that. We have 1/2 times 9 times 4. That gives us, if you check that work with a calculator, 18. And that means the area is 18 centimeters squared, which is the correct area. So we know 4 centimeters and 9 centimeters are the numbers we're looking for. Example 2, the length of a rectangle is 7 inches less than twice its width. The area of the rectangle is 240 square inches. Find the length and the width of the rectangle. Round to the nearest tenth of an inch. So the first step is to remember the formula for the area of a rectangle, and that's length times width. So this is a formula that you should remember. The area is length times width. I will list down my variables A, L, and W. In the question, we're given the area. The area is given to be 240 square inches, so I'll write 240. The length is 7 inches less than twice its width. So the equation for that is L equals 2W minus 7. It's 7 inches less than its width. So always have that minus 7 after, because that word then tells me I have to subtract from twice the width. The width, it's not given, it's unknown, so we'll leave that as a question mark. Now we could substitute into the formula. We have 240 is equal to the length, which is 2W minus 7. The width, we'll multiply that by W. Now you want to be extra careful. When I did the substitution for the length, I made sure to put parentheses around 2W minus 7 because we're multiplying by the entire length. So this gives me 240 equals, now we could distribute here, 2W times W is 2W squared. Negative 7 times W is negative 7W. The next step is to set this equal to 0 and see if this is factorable. So we'll subtract 240 to both sides. This gives us 0 equals 2W squared minus 7W minus 240. Now if you were to try to factor this, this would be quite difficult. We have to find two numbers that multiply to get negative 240, but add up to negative 7. This is not possible. There's no pair of numbers that work. So this is not factorable. So we've got a couple options. We could either use the quadratic formula or complete the square. I will choose the quadratic formula because the middle term is odd. If I were to complete the square, I would have to divide b by 2, and that's going to be a lot of work. So let's use the quadratic formula. Recall, we have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This is the quadratic formula with the variable x. But we have a w, so we'll replace that x with a w. The a is going to be the 2. The B is going to be negative 7. So our C is negative 240. Let's substitute it into the formula. We have W equals negative 7 plus or minus the square root of negative 7 squared minus 4 times A, which is 2, times C, which is negative 240. And we're going to divide that by 2 times 2. 2 times A, or 2 times 2. On the left side, you'll have a positive 7, so W equals 7 plus or minus. Now we could simplify the inside. Negative 7 squared, that's positive 49, minus 4 times 2 times negative 240. Using a calculator, you can get 1969 from that calculation. And then we'll divide that by 4. So we'll need to use a calculator now. I'll use Desmos for this. For the first one, we'll enter 7 plus the square root of 1969 over 4. To enter this, I like to start with the fractional button. So the A over B button, that gives me a fraction. And then we'll put 7 plus the square root of 1969, and then we'll divide that by 4. So this gives us our first solution, and that's 12.8. We'll round that to 12.8. So the width is 12.8 inches, or the width is equal to, we'll do the negative version now, 7 minus the square root of 1969 over 4, I have negative 9.3. The width is negative 9.3, but that doesn't make sense. You can't have a width that's negative, so we'll throw that answer out. That means the width is 12.8 inches. But we're not done yet. We have to find the length. To find the length, we'll use our previous equation that we created ourselves, which is the length equals 2W minus 7. So we'll say L equals 2. We'll substitute the W here into the equation. This is 2 times 12.8 minus 7. And we'll use a calculator for that. And that gives me 18.6. So that means the length is 18.6 inches. We have the length and we have the width. Now to check our work, I need to multiply the length times the width. So we'll just do that quickly here. To check our work, we'll look at the area. The area is 240 inches, 240 square inches. So to check our work, we'll need to multiply 12.8 times 18.6. This is the length times the width, and that should be close to 240. And that gives me 238.08. Why is this answer not exactly 240 centimeters? Well, the reason is we rounded. We rounded our width to 1 decimal place, and we rounded our length to 1 decimal place. But the answer is pretty close to 240, so I'm confident that our answers are right. 12.8 inches for the width and 18.6 inches for the length. In example 3, a right triangle has a hypotenuse that measures 18 inches and one of its legs is 6 inches long. Find the length of the other leg to the nearest tenth of an inch. First step is to draw a right triangle, which means it has a 90-degree angle. So this is a 90-degree angle. The hypotenuse, that's always opposite of the 90-degree angle, so that's the longest side of the right triangle. We know the hypotenuse is 18 inches, and one of its legs, this right here, is called a leg. This going up and down is a leg, and on the bottom here, that's also called a leg. One of its legs is 6 inches long, so we'll just call this leg 6 inches long. Find the length of the other leg. So we don't know the length of this other leg, so we'll just call that x. Now, how do we find the length of the other leg? We need to recall the Pythagorean theorem. The Pythagorean theorem. The Pythagorean theorem states for a right triangle with legs A, B, and hypotenuse of C, that a squared plus b squared is equal to c squared. So that's the Pythagorean theorem. The leg is 6 inches and the other leg is x. So we could substitute this into the formula as 6 squared plus x squared equals 18 squared. 6 squared is 36. Plus x squared is x squared, and we can calculate 18 squared as 324. Let's subtract 36 to both sides to isolate that x squared term. This gives us x squared equals 324 minus 36 is 288. Now, how do we solve for x? We're going to take the square root of both sides. We'll take the square root of both sides. Don't forget that plus or minus. And so this gives us two possibilities. We have x is equal to plus or minus the square root of 288. The square root of 288 with my calculator is approximately 16.9705 and so on. So this rounds to about 17. So this rounds to 17.0 and our units is in inches. Now there was two possibilities. We had a negative 17 inch and a positive 17 inches. We're going to take the positive answer because the negative one doesn't make any sense. So we have one solution here, x equals 17 inches. So the length of the leg is 17 inches. The Pythagorean theorem again only works for right triangles, triangles with a 90-degree corner. Let's look at example 4. A 5-foot ladder is leaning against a wall. If the bottom of the ladder is 3 feet from the base of the wall, how high up the wall is the top of the ladder? So let's draw a picture. I have a ladder here that's leaning against a wall. And this is a 5-foot ladder, so we could label that as 5 feet for the ladder. The bottom of the ladder is 3 feet from the base. So this is 3 feet. And we're looking for the height. We don't know what the height is, so we'll give that a name. Well, let's call that x. This looks like a right triangle, and it is. This is another right triangle. So we could use the Pythagorean theorem. A squared plus b squared equals c squared. Now the a is x, so we'll say x squared plus the base here is 3, so we'll say b is 3 squared. And this is equal to c, which is 5. The hypotenuse is always c, and that's going to be 5 squared. X squared is x squared. 3 squared is just 9. And 5 squared is 25. We'll subtract 9 to both sides now to solve for x. And so this gives me x squared is equal to 25 minus 9 gives me 16. take the square root of both sides. Don't forget that plus or minus. In the end, we're actually just going to take the positive. And so we have x is equal to the square root of 16, which is 4. So we have two possibilities. X equals negative 4 feet, or x equals positive 4 feet. And clearly we're going to throw out the negative 4 feet. That one doesn't make sense. And so the height of this from the floor to the top of the ladder is 4 feet. In example 5, the Modesto Airport is located 120 miles north and 50 miles west of the Visalia Airport. If a plane flies directly from Visalia to Modesto, how many miles is the flight? So we'll draw a picture. I know north is facing up here, the south is opposite of that, east is on the right, and west is on the left. Let's figure out the picture here. We have to travel 120 miles north, so we're going to go up. That's going to be about 120 miles. And then we're going to travel 50 miles west. So it's going to form a right angle here, 50 miles west. And then the question is, if we fly directly there, connecting the 2 points, and it is a right triangle. So let's make sure our picture is clear. The distance here is 120 miles. The distance here is 50 miles. We're actually looking for the hypotenuse. The hypotenuse is unknown, so I'm going to call that x. This is a right triangle, so I can use the formula for the Pythagorean Theorem. It says a squared plus b squared equals c squared. The legs, in this case, is 50 and 120. So we have 50 squared plus 120 squared equals x squared. Again, the hypotenuse is always the longest side, so in our case, x is equal to c. 50 squared is 2,500. 120 squared is 14,400. And we have x squared here on the right. Let's add these two numbers up. We get 16,900 is equal to x squared. Let's take the square root of both sides. Don't forget that plus or minus. But in the end, we're going to throw out the negative. So we're going to have the square root of 100. The square root of 16,900 is 130. So we have x equals plus or minus 130. We're going to throw out the negative because negative 130 miles doesn't make sense. So we'll say x equals 130, or x equals negative 130. We'll throw that one out. So our answer is 130 miles. It takes us a distance of 130 miles to go from Modesto to Visalia.